Hello all, this is Satvik from Eclipse Defender team. Our team focuses on Eclipse attack. First of all, a quick recap from Tier 1 presentation. In Tier 1, we discussed about P2P networks, victims inbound and outbound connections and how they are filled for a node and how susceptible they are to an attack. We also discussed about discovery table, DHT, and how this table is filled. We also discussed about lookup table. Later on, we discussed about one particular type of Eclipse attack called false friends attack. We discussed about how an attacker can easily generate ECDSA pairs and can eclipse a node completely within 5 days. Now today, we present how we want to tackle this problem and how we want to design a specific algorithm which can mitigate or increase the difficulty for an attacker. Our new algorithm assumes that the attacker node will typically tries to bring the inconsistencies in the blockchain network. Here is an NFT smart contract example which shows how the hijacker hedge node induces inconsistencies by providing false information to Alice A node, which is a victim node. In this blockchain P2P network, Alice A has connections from P, Q, R, S, T, X, Y, Z, and H, where H is the hijacker and all the other nodes are under attacker's influence. In this example, there is a Ethereum's NFT smart contract that is used to auction off a digital cat. This contract has variable X that counts the number of bids made on the cat. Alice made a decision to spend Ether to bid on the cat if X is less than 5. However, hijacker hedge node could show Alice this particular view of the blockchain where X is less than 5, causing Alice to sign a bid transaction T. Now, hijacker hedge will share this transaction T with other nodes, causing the inconsistency in this blockchain P2P network. Our new algorithm works in finding these kind of inconsistencies and blacking out the susceptible nodes. Recently, there are lots of NFT attacks happened. This slide presents a particular NFT auction attack. Now coming to our algorithm, we will target a vulnerability to negate it as shown. This new algorithm works and targets uh, the inbound and outbound connections to decrease the attack risk. So the vulnerability which we target is as shown. We know that currently the get flow is such that whenever inbound slot is available, it is filled with an active node. This makes attacker to easily penetrate and become the inbound node with constant ping pongs. Outbound slots are also susceptible in a similar way. This susceptibility of outbound slots was discussed in Tier 1. Coming to algorithm, uh, our algorithm tackles this kind of vulnerability. Even though the inbound slots or outbound slots are non-empty, our algorithm wants to make a 5 to 10 find node requests uh, and connect with random nodes through lookup algorithm. This is needed to decrease the inconsistencies. If the victim node finds out there are inconsistencies from these 5 to 10 new nodes data, then the victim node blacks out the present inbound slots and outbound slots and stores the IP address of the susceptible nodes. This DB store will be shared in the BCT network once the victim becomes free of attacker nodes. This will be through a new intelligence algorithm that we want to add. We want to share the intelligence or the stored data across the BCT network to decrease the attack risks on the other nodes as well. Now, our next action item is design a proper algorithm on the lines we just discussed, make a flow chart and signaling chart for the next final presentation. Thanks for listening.